Look around your home right now. An ice cube in the fridge, the water in your bottle, the air you're breathing this very second. Here's the strange part. They all can be the exact same thing, just wearing three different costumes. Want to see the costume change? Let's go! Welcome to LNM Learning, where we make learning fun, simple, and easy to understand. Today's topic is matter and its composition, and the three states of matter. First, a quick question. What is matter? Easy. Matter is anything that takes up space and has weight. Your school bag? Matter. The water you drink? That's matter too. Even the air you can't see. So take an example of a balloon. Blow up a balloon and it puffs out. So air takes up space too. That makes air matter as well. So almost everything around you, big as a plane, small as a needle, is matter. Now zoom in really close. If you could shrink down and look inside anything, the book, the ice cube, a drop of juice, you'd see it's made of billions of tiny, tiny particles. We call them molecules. Picture a giant pile of invisible beads. How those beads are arranged is the whole secret to today's lessons. Because the same beads, packed in three different ways, give us three different states. Are you ready to meet them? Now let's take the example of water. Water wears all these three costumes. In the freezer, water becomes ice, hard, solid, and you can hold it. Leave it out, it melts into liquid water. It flows, it splashes. Heat it on the stove, and it turns into steam, a gas that floats away. Same water, same molecules, but three totally different forms: solid, liquid, and gas. That's what we mean by the three states of matter. Now let's find out why they're so different. Let's start with solids, like ice, a brick, or a school bag. Imagine a crowded bus where everyone's squeezed in tight, shoulder to shoulder, holding on firmly. Nobody can move around. That's exactly how molecules sit in a solid, packed super close, pulling on each other strongly. So a solid keeps its own fixed shape, and you can't squeeze it and make it smaller. Have you ever tried to press a brick? It won't shrink one bit. That's why solids feel hard and stay the same shape. Now let's move on to liquids like water, juice, or even milk. Loosen that crowded bus a little. Now the kids can slide past each other, but they're still close. That's a liquid. The molecules slip and slide, so a liquid flows and takes the shape of whatever glass you pour it into. Pour juice into a tall glass, it takes the shape of the tall glass. Pour it into a bowl, it takes the shape of the bowl. But the amount stays the same. Squeeze a liquid, only a tiny bit. It flows, but it won't shrink much. Lastly, gases, like the air around you. Now imagine recess. The kids burst out of the bus and run all over the playground, far apart, going everywhere. That's a gas. The molecules spread out with big empty gaps between them. So gas has no fixed space but fills the entire room. Ever smell breakfast cooking from the kitchen? That's gas molecules flowing into your nose. And because of those big gaps, gases are super easy to squish, meaning they are highly compressible. Now let's try an experiment to understand the gaps between the various states of matter. Let's take a glass of water, mark its level, and stir in a spoon of salt. The salt disappears, but the water level doesn't rise. Where did the salt go? It slipped into the tiny empty spaces between the water molecules. Those gaps are called as intermolecular spaces. The biggest of the gaps are in gases, small in liquids, and almost none in solids. But wait, if there are gaps, why doesn't a solid fall apart? Because of the pulling force between the molecules. called the intermolecular force of attraction, in solids the pull is super strong. That's why they stay hard and hold their shape, like kids gripping tight in a line. In liquids, the pull is weaker. In gases, it is so weak that the molecules just fly off. Strong pull plus small gaps, the combo makes solids the toughest of them all. Now let's try another experiment. How does ice turn into steam? Through heat. When you heat something, its molecules get extra energy, what we call as kinetic energy, the energy of movement. Picture an ice on a hot pan. The molecules start shaking, then they break free and slide. It now turns into water. Heat it more. They zoom apart completely. Now it turns into steam. So heating pushes matter from solid to liquid to gas. More heat means more movement, means more freedom. Now let's run it backwards with cooling. Cooling takes away energy, so the molecules slow down and come closer again. Steam, when it cools, turns back into water. That's why droplets appear on a cold water bottle on a hot day. Cool water enough and it freezes into ice. So heating and cooling are like a two-way switch. Heat spreads molecules out, cold pulls them back together. That's how one thing becomes solid, liquid, or gas. Now, one last surprise. Here's a cool magic trick. Have you seen a white naphthalene ball in a cupboard slowly shrink and vanish? It went straight from solid to gas, skipping liquid completely. The magical jump is called sublimation. It happens with camphor too. Light it and it just disappears into thin air. So sometimes a solid can leap right over the liquid stage. Isn't that a neat magic trick? Matter is everywhere. You see all this every single day. Ice cubes in the freezer, solids. Milk you pour onto the glass, liquid. Steam rising from a hot cup of tea, gas. The smell of dinner reaching your room. Gas molecules are on the move. You've been a matter scientist your whole life without even knowing it. Once you start noticing, you'll spot solids, liquids, and gases everywhere you look. Time for a quick recap. Let's lock this in. Everything around you is matter. It takes up space and has weight. Matter is made up of tiny particles called molecules. Solids pack molecules tight with a strong pull, so they stay hard. Liquids are looser, so they flow and they take the shape of a glass. Gases spread out with big gaps and fill the room and are squished easily. The space between particles is called as intermolecular spaces, biggest in gases, thinnest in solids. Heat spreads molecules out and cold pulls them back in. That's how ice, water, and steam are all the same stuff. And sublimation, solids jumping straight into gas, like that vanishing naphthalene ball. So you see, ice, water, and steam were never really different, just the same molecules in different costumes. If this video made the states of matter feel easy, hit that like button and subscribe, and tap on the bell icon so that you never miss a lesson. Let's learn together, one smile at a time.